Hello, my dear champions. Welcome back to the class. Today, I'm here to discuss one important concept because we know now that the calculus season is right here with us. Everyone is solving or breaking their head solving questions of calculus. And whenever in those questions, we see some difficult type of questions of limits, is we start realizing, we start regretting, I should have learned these concepts better, a little bit better in our PU1. Have you felt that way? Did you ever feel this? Yes, right? Because in the calculus, you'll find time to time application of limits will be there. Either it's going to be an advanced question of integration. You might find this somewhere in your differentiation as well. You'll find this in your continuity as well, right? The first principal derivative is based upon limits only, correct? So my point is, this topic which you ignored or which you might have forgotten a little bit from your first PU prep, it's time to revise now and make the most of our calculus season which is ongoing at this point of time. Okay, so I'm going to revise standard limits, what different ways we can solve the questions. I'll take example of each of the categories and some special type of limits which is there. All will be discussed in this particular class. So if you are interested in this, do not forget to hit the like button, this class, hit the like button and share this session with all of your friends who are interested in learning maths in a simpler way with me on our channel, Diksha Karnataka. Let's start the class. Let us start the class from the very basic, which is what is a limit? What is a limit? So very simple. Why do we need it? There are various cases, sir, where I require. For example, if I look at this example, okay, which is over here, you can see x square minus 1 upon x minus 1. X square minus 1 upon x minus 1. If you look at this case over here, and I ask you to find the value of this function 1, f of 1, what is the answer? So it is undefined because you're going to get something as 0 by 0, which is a indeterminate form. This is called as indeterminate form. This is indeterminate form. So how do you solve it? Difficult to find, but if you apply a condition that x is not equal to 1, x is not equal to 1, then we can simply factorize this as x minus 1 times of x plus 1 upon x minus 1, and we cancel it out, and my function now, if you write this again, f of x, you can write this as simply x plus 1 provided x is not equal to 1. This can be redefined and we can find the limiting value of this function at the point 1. We can find the limiting value, means when x tends to 1. What's the meaning of tends to 1? It is very close to 1, either close from the left hand side or right hand side, but not equal to 1. So x tends to 1 but not equal. We can find the limiting value, okay, and that we can use in our questions. So when you write x tends to 1, it means x is not equal to 1, it is close to 1. Can you define it? Can you define this value x tends to 1? You cannot, it's undefined. 0 points, basically 0.999999 till what point? You start writing 0.99999 and the point you stop, it will become undefined. Let's say I want to stop after here, sir, it will be undefined because you can still go further. You can still go further. So x tends to 1, we cannot define it. That's why we write this as this value is, okay, the function is undefined, of course, is forming this undeterminate form, but yeah, x tends to 1 has no definite value, this has no definite value, but the limit value that if you solve over here and put the value as 1, that becomes 1 plus 1, which is 2, that will be always definite. So even though when you're writing x tends to 1, this value is indefinite, you cannot basically write an exact value for that, it's not finite, but this value of limit will always be finite. So any limit value, okay, always will be finite. All right, guys, let's move on. Okay, let us move on. Let us look at some standard limits cases when x tends to a in this, what is this, polynomial form, x power n minus a power n divided by x minus a. This is the formula. You can write directly answer as n times of a power n minus 1. This is the limit. You can take example also over here, x cube minus 8. So you can see this is also 2 cube. This is also 2 cube. This becomes 3 times of 2 square, that is 12. Again, standard limits for trigonometric function. Sin x by x when x tends to 0. Here when x tends to 0 is there. Please be careful of what is the limit condition also. not only the expression but also the limit condition. If this value changes, this will be different answer. Okay, it becomes 1. This is again 1 minus cos x by x becomes equals to 0, and tan x by x forms the same condition as limit sin x by x, x tends to 0. So be careful around what is the limit value and some standard limit forms. All right, algebra of limits, right? You must have recently learned algebra of continuity, right? Algebra of derivative also. So same way we have algebra of limits. If I have function limit value, limit of the function fx as L and limit of the function gx as m at the point x tends to a, then if you go for f and g, answer becomes simply, you can operate basically limit of f plus limit of g separately, that will come as L plus m. Same goes in the case of difference also. Limit of f will be L, limit of g will be minus basically m. This also works fine, correct in the case of product, also works in the case of quotient, provided this m is non-zero because it is in denominator, so has to be non-zero to be defined, right? And kf, if you have a constant multiplied scalar constant, you can take it outside the limit and apply the limit on the function f for, the scalar multiplication basically will come as kl, k times of l. L is the limit value of f when x tends to a. Make sense, guys? Examples also given for each of the cases. Yes, these are very simple things, by the way, very, very simple things. Now, how do we evaluate different types of limits? I know all of you will remember it. Just give me 2 minutes and you will also recall it right now that yes, we learned this in our grade 11 or PU1. Okay, have a look. So there are certain methods. One of them I just showed you, use of standard limits, but in some questions standard limits will not be applicable straight away, means directly. So we have to use some type of substitutions. Okay, we take x equals to a, and this is the simplest form, by the way, forgive me. This is the case where there is no indeterminate form. When there is no 0 by 0 or any other indeterminate form possible, whenever you have no indeterminate form. So you'll have many questions, many function given after substitution of the limit value, the limiting condition, will be not forming a indeterminate condition. This is not indeterminate, not indeterminate. If those conditions are applicable, means directly you can substitute the value a and get the answer. Let's say here I'm writing x tends to 2. It becomes 2 square is 4 plus 3 into 2 is 6, becomes 4 plus 6 is 10, right? So you can have cases like this. That's the simplest way of solving using or finding the limits. Again, as I said, there can be multiple questions where you can't solve with directly the formulas that you have that I've shown you before in this slide, in this session. You are not going to be able to apply directly. Then what do? You can use factorization, you can use rationalization also to perform or to evaluate the limits, right? So this is a very simple question, by the way. Check here. So you can apply this, you can solve this using your limits as well. Check. If I go with the standard limits, x square minus 2 square upon x minus 2, when limit x tends to 2 is what? Is 2 times of n times of a power, which is going to be 2 power n minus 1. Okay, so 2 minus 1. Check this out. This becomes what? This becomes 2 times of 2 minus 1, 2 times of 2. How much is that? 4. This is the standard limit. This is the use of standard limits. Let me show you here. N a power n minus 1. Here n and a is both same. That's why you can see 2 times of 2 power 2 minus 1. You can use the factorization also. So you're going to have over here x minus 2, x plus 2 upon x minus 2. This cancels. You have limit x plus 2 when x tends to 2 will become, this will be the case of direct substitution. Answer becomes 4. Answer becomes 4. You can see the same result over here. Next is rationalization. Next is rationalization, the third method. Check here. We have a square root of x upon x minus 4 when limit x tends to 4. Let me show you this. The question is this: limit square root of x minus 4 upon x minus 2. Is it x minus 2 and there is x minus 4 actually, sorry. This is 2 and this is 4. when x tends to 4. So we can rationalize it over here. Let's look. We can do root of x plus 2 and root of x plus 2. Rationalize, you're going to get x will be root x square, so x minus 4 upon x minus 4, this value, and this will be root x plus 2, limit x tends to 4. This part cancels. Okay, we have the answer as limit 1 upon root x plus 2. Am I right? And when we have x tends to 4, you can check. You will have answer as 1 upon root of 4 is 2 plus 2. Answer becomes 1 by 4. 1 by 4. Have a look. Yes, I've solved this question over here using the help of the third method of, which is going to be method of rationalization to evaluate the limits. Clear? Yes. Now, what's the meaning of left hand and right hand limits? Let's recall this. So basically, if I let's say have on the number line, I have a point A, and I want to find the function's limiting value at the point A from right hand side, means I come close to A from right hand side. I try to reach A from right hand side. This will be something like in this interval, A plus delta. Delta means very small value close towards, basically if you go from interval A to A plus delta, you'll have right neighborhood of the point A. Same way if you go from here, same value, take this from here, you'll be having A minus delta. So from the left hand side, you'll have this part will be called as left neighborhood. Right neighborhood with A to A plus delta. This is A minus delta to A is the left neighborhood. So when you try to find out the limits, the function value in the right neighborhood, basically very close to A from right hand side, that is called as right hand limit. So limit of the function fx when you approach from A plus means from right hand side of A, and here A minus means from the left hand side of A. Don't take minus A. Don't take minus A. It is A minus means from left of A. Then the expression is actually this. So if I have limit fx when x tends to A plus, let's say we replace x by A plus h. Replace x by A plus h, then think about it. If x goes to A, if this value becomes A, h will become 0. H tends to 0, you'll have f of A plus h. That's how you write it. Okay. Whereas in this case, if you write limit of fx when x tends to A minus, again you replace x by A minus h in this case. A minus h in this case. Again, if this value x is going to A, this will become what? 0. So write this as limit h tends to 0, f of replace x by A minus h. This is how you define the left hand and right hand limit. And when we have these two values equal, then we say limit exists. Then we say the limit of the function at the point A exists. Okay. For example, check here, mod of x by x is what we have. This example is mod of x by x. Let's look at this. Mod of x by x. Okay. This is the function. Try to find this value after 0, means when it is more than 0. It will become plus x by x. How much is that? 1. But when you go and find this on the left hand side of 0, which is negative, it will become minus x by x. This will become, mod will be minus x. So this becomes what? Minus 1. Check here. Your right hand limit in this case is coming equal to 1, and left hand limit is coming equal to what? What is this? Minus 1. You can say that the LHL value is not equal to RHL. Clearly, the limit does not exist at x equals to 0. The limit of the function, this, does not exist at the point x equals to 0. Please check. Limit does not exist at which point? At the point x equals to 0. Clear, guys? Clear? Okay. Right. Now, we have some other type of limits also when we're dealing with polynomial limits. This can be there in the rational form also. That's why it is rational form. In rational form, we have to ensure that g of a, basically in the denominator, is non-zero. If it is fx by gx, no, this has to be non-zero. Okay, and we have to check for the indeterminate form 0 by 0 or whatever other forms are there. We have to check for all the indeterminate form. Okay, so whenever we are dealing with those questions, most of the problems are solved using what? If it is direct in nature, we substitute and find the value. Example is on your screen right now. Put the x as 2. You get 4 into 3 is 12. This is going to be minus 4 and 1. Direct method. In the case of rational, you have to factorize it and then solve it. I've done the example like this right now. Okay. But this is a very special case. And this sometimes does come in your CET. What is this? Limits when it goes to, for the same rational function. For the rational function, if you have f by g, and they write limit x tends to infinity. For example, in this question, can you see that? 3x square plus 1, 5x square minus 2. 3x square plus 1 and 5x square, is it minus 2? Yeah, minus 2 is what we have. And the limit is what? X tends to infinity. X tends to infinity. How do you solve this question? So in this kind of question, no, you will check for the highest degree. Wherever it is there, take that common. Here we have x square in both. Take x square common. You'll end up with what? You'll have 3 1 upon x square. Take here again x square common. You'll have 5 minus 2 upon x square. Put the limit back. This is cancelled, sir. Okay, now substitute 3 plus 1 upon infinity if you have this condition, and here also 5 minus 2 upon same thing. Check here, this will become what? 0. This also is 0. Answer is 3 plus 0, 5 minus 0. Answer becomes what? 3 by 5. So whenever you're dealing with the polynomial functions, or basically in rational form, and you have limit x tends to infinity, the question is solved using what? Your checking the degree of the polynomial in both numerator and denominator side, take it common, and then substitute the x value to infinity. Because when you write 1 by x and you write x as 0, what happens? 1 by x goes to infinity. So same way, if you're writing what? 1 by x and x goes to what? 1 second. Same way, let's say you're writing t goes to infinity and you're writing what? 1 by t, so will become what? This will go to, or this will be equal to 0. Yeah. Great. This is clear. All right. Okay. Exponential and logarithmic limits. Again, these are standard limits. You have to remember these formulas. Whenever you have e power x minus 1 upon x, the value for limit when x tends to 0 is 1. Right? Please remember the standard form, very, very useful. X tends to 0 when you have limit a power x minus 1 upon x is ln a. This is basically ln e. So ln e is what? 1. This is ln a, the base of this exponential part. Again, if you have, I've given example also on each of these. Please go through it. If you have ln of 1 plus x upon x, this value is again 1. And if you have ln of 1 plus x power 1, power of 1 by x, whatever is this value over here, this is the reciprocal form. Answer will be taken as e. Try to evaluate this. You'll have also as e only when you take, this is again, this is taken as 0. Please check x tends to 0. But here the value is 1 by n. Here it was x. Please check. When it is x, sir, this is x tends to 0. That's why the result is e. But you have 1 by form. That is the reciprocal form over here. That's why n goes to infinity. If you want to substitute, let's say, if you will take 1 by e equal to t, right? This will become limit 1 plus t power 1 by t. Limit 1 plus t power 1 by t. Correct or not? If you take 1 by n as t, it will become 1 plus t power n will be 1 by t, and this will be equal to what? E, provided, cross check. If 1 by n is, sorry, if n is infinity, then 1 by n will be what? 0. So you'll have t tends to 0. Now if you want, cross check this part with this part. They're same. Limit 1 plus x power 1 by x is e. Limit 1 plus t power 1 by t is e when x tends to or t tends to 0. They are the same condition, just ulta. If you are confused why it is x tends to 0, sir, and why here n tends to infinity, I explain the reason right now. Okay. Again, the same we have repeated there as well. You know, whenever you have kx equal to 0, you just take kx as 1, basically variable. So kx by kx, if you have, answer will be still 1, as it was x by x. Same goes in the case of tan also. They are both limit x tends to 0, 1 only. If you have just kx by x, how do you solve it? So you write this sine kx. So you need kx over here, right? But you can't, there's only x present. So you multiply k over here also, so that it cancels. This value becomes equal to 1. You'll have only k left. That's why you'll have k into 1 as k. And over here, just opposite, it will become 1 by k, because here the sign part is in the denominator. Okay. Here you'll have value as 1 by 2, because if you use the limits over here, you're going to get 1 minus cos as 2 sine square x by 2. You need to introduce the same thing over here. That's how the result is 1 by 2. Looking at this question, sine 5x by 3x, how do you solve it? So if I have sine 5x, I know that, let's keep 3 outside. I know I need the x. It is 3 into x, but I need 5. So multiply 5 over here. I have to multiply 5 over here also. So basically I'm getting what? Now it is sine 5x, 3 separated. I multiplied 5 over here, so over here also. Now write limit x tends to 0. This part becomes equal to 1. Answer is 5 by 3 into 1, which is nothing but 5 by 3. So please check. Right? So I hope this makes very much clear for you. Okay. All right. So again, some questions I have given you to practice on the different types of question in exponential function and log function. Whenever you have e power 3x minus 1 divided by x tends to 0, answer will be 3. If you have ln 1 plus 5x upon x tends to 0, answer will be 5. And limit 3 power x minus 1 upon x will be, answer will be ln 3. So all different forms I have taken, just one example to show you how they work. Try this out once. Okay. Now this is one condition that we use a lot in our KCET problem to solve it faster. It's not there for board, so we cannot use it in board's questions, but we can use certainly in our MCQs, right? But when will you use it? There's a condition for that. So L'Hopital rule is used only when you are getting the form of 0 to 0 or infinity to infinity. Whenever you have these two indeterminate form, we use L'Hopital rule to make our question easier and faster to solve. So how do you solve it? So if you have a rational function fx by gx, limit you want to find out of that, you can do the same thing by differentiating the function as f dash by g dash. You differentiate the function both, okay, numerator and denominator, and continue with the same limit, you will get the same result. Check here. Verify the limit gives 0 to 0 or infinity to infinity. Check for these two conditions for indeterminate form. Differentiate numerator as f dash of x, differentiate denominator as g dash of x, and then apply the limit again. If you're still getting the indeterminate form after doing this step, apply again same approach. Keep continuing, you'll get the answer as it is. Okay, let's apply in this question. Sin x by x we have, sir. What is the answer for this? We know the answer is 1. Let's try. Limit sin x by x when x tends to 0. Check first for indeterminate form. Sin 0 is what? 0, and divide by 0 will be indeterminate form. Differentiate, keep the limit as it is. Sin derivative will be what? Cos. Derivative of sin is cos, x will be 1. Put cos 0 becomes 1. And this we remember, this is the standard limits also of trigonometric functions, 1. Here, in this case, we can solve this question using factorization. We can solve this question using factorization, but we can solve it using L'Hopital rule also. Just put x value as 1 first. You're going to get 1 minus 1, which is 0. Numerator. This also is 0, means this is forming a indeterminate form of 0 by 0. Differentiate. Limit x tends to 1. Differentiate numerator. This part, differentiate. This is the fraction, right? Differentiate. You'll get 2x minus 0. Over here, you'll get 1 minus 0, right? Now substitute x value as 1. You're going to get 2 times of 1 This is 0, this also is 1. Answer becomes 2. So if you solve using the standard conditions of factorization or standard limits, you have the same answer. If you want to solve it using L'Hopital, also you have the same answer. That's why in the board side you don't use L'Hopital, you can use simply directly what I've taught you, different methods to find or evaluate limits. But in CET or in MCQs, you can certainly use this method to get the results faster. What about infinity problem, sir? Okay, if you have this, let's say x tends to infinity, limit x by e power x, differentiate, na? Differentiate. X will be 1, derivative of x is 1, e power x remains as e power x. So e power infinity is how much? Do you remember? Look at the graph of e power x. This is the graph of e power x. When x goes to infinity, y also goes to infinity. So you'll have basically 1 upon infinity, and you know this is nothing but equal to 0. Whenever you have 1 by infinity, 1 by 0 is infinity, and 1 by infinity is also 0. Okay, so e power x will become e power infinity, that is already infinity, so 0. All right, now this case you try and check, let me know in the comment section. X square e power x, apply L'Hopital and let me know what is your answer for example number 4 of infinity forms. Okay, let us move on. This is a summary. So limit is what? It's the value of function that is when x approaches to a but it is not equal to a. The meaning of x tends to a is it is not equal to a. First meaning is that only. Okay, again, what is left neighborhood, right neighborhood? I have explained that already. Okay, some standard form, sin x by x, tan x by x. When x tends to 0 in both the cases, here also x tends to 0, e power x minus 1 upon 1 by x is 1. So I have already given you all these formulas. Please go and check it out over there. Let's quickly move on. Okay, some questions. So I have 3. I'm going to solve 2. 1 will be for you to give me in the comment section. How to solve it, sir? I can use L'Hopital or anything. If you want to use factorization, use this x minus 3, x plus 3 upon x minus 3. Since x tends to 3 is there, means x is not equal to 3. I can cancel these two. Put the value 3 over here, it becomes 3 plus 3, which is 6. That's option B. Clearly evident. Clearly evident. Okay. Next. Sin 3x by 3x, standard limits is there. Answer will be what, sir? 1. This is standard limits. You can use L'Hopital also, but answer is 1. Please check. Have a look. Okay. And for this question, again, I've given the answer already, but it's also standard limits. Answer will be 1 e power x minus 1 upon yx when x tends to 0 is what? Equal to 1. And this was it in the class where I talked about revision of limits, different type of questions, some examples, all the forms, how to apply them, different way to evaluate the limits, all have been discussed in this particular session. And do not forget to check our reveal on Monday, because there's an important reveal coming for all of you on Monday that will help your preparation. You know, that will basically boost your preparation to the best way. Okay, and for that you to just simply subscribe to the channel and click on the notification bell. Go and click on that. Live is already scheduled. Go and check that the scheduled live and keep the notification bell on. I'm telling you, we have done something very, very, very phenomenal. It'll help you out in your preparation. Go and check it out right now. Okay, that's all in this class. I'll see you in the next one. Till then, take care. Bye bye. All the best.